This is day 13 of Advent of Code 2024 Done and Go, and this challenge is called Claw Contraption. Next up, the lobby of a resort on a tropical island. The historians take a moment to admire the hexagonal floor tiles before spreading out. Fortunately, looks like the resort has a new arcade. Maybe you can win some prizes from the claw machines. The claw machines here are a little unusual. Instead of a joystick or directional buttons to control the claw, these machines have two buttons, labelled A and B. Worse, you can't just put in a token play. It costs 3 tokens to push the A button and 1 token to push the B button. With a little experimentation, you figure out that each machine's buttons are configured to move the claws a specific amount to the right along the x-axis and a specific amount forward along the y-axis each time that button is pressed. Each machine contains one prize. To win the prize, the claw must be positioned exactly above the prize on both the x and y axis. You wonder, what is the smallest number of tokens you would have to spend to win as many prizes as possible? You assemble a list of every machine's button behavior and prize location, the puzzle input. So for example, A is x plus 94, y plus 34, and B is x 22, y 67, and so on. So the list describes the button configurations and price location of 4 different claw machines. For now, consider just the first claw machine in the list. Pushing the machine's A button would move the claw 94 units along the X and then 34 along the Y. B is 22 along X and 67 along Y. We're trying to get to X of 8,400 and Y of 5,400. So the cheapest way to win the prize is by pushing the A button 80 times and the B button 40 times. And doing this would cost 80 times 3 tokens, and then 40 times 1 for B, 280. For the second and fourth claw machines, there is no combination of A and B presses that will ever win a prize. For the third claw machine, the cheapest way to win the prize is by pushing the A button 38 times and the B button 86 times. Doing this would cost a total of 200 tokens. So, the most prizes you could possibly win is 2. The minimum number of tokens you would have to spend to win all 2 prizes is 480. You estimate that each button would need to be pressed no more than 100 times to win a prize. How else would someone be expected to play? So figure out how to win as many prizes as possible. What is the fewest tokens you would have to spend to win all possible prizes? Okay, so let's get started. So let's take a look at what the input is like. So I've got it like this. So we need to first go through the lines and get the buttons. I wonder if there's any minuses in here. No, it's all forward. I'm trying to figure out just how best way to get the values we want from it. So let's take a look at what the input looks like. Lines declared not used. I'm using it right there. Oh, okay, there we go. So how does this look? So because there's 2 of these in a row, we might be able to do new line split. Maybe we should just print the first one. So I want to get all of the instructions grouped together. Okay, cool. We've got exactly that. So we'll do what do we call this? We'll call it machines. So we've got the machines, and then we can do for machine in range machines. Now we can do lines equal to machine dot split. No, this should be strings dot split on machine, and this will be new line. So we want to now extract these values from it. So we will first define a bunch of variables. So AX, AY, BX, BY, PX, PY. So button A, button B, and prize. And these are all ints. So with lines split, format dot scan, and then F, so be lines 0, and then we'll be extracting from button, basically I'll just copy all of these for now. So button A like this, but we have %D, then the values in that are going into AX, AY. So now we do the exact same thing on line 1, but button B, BX, BY, and now we do it once more, but for prize, and that is in this format, so X equals Y equals PX, PY. And just to make sure we've done that all correctly, we are going to format print line AX, AY, BX, BY, PX, PY. And that is not working. Oh, actually, so for it to actually update the value and we have access to it, we need to pass the reference to it like this, because it will update the value within the function, but we won't get it here, like down here, so it says 0. So we pass the reference to it, it will update it, and it will actually update these variables. So now that should work. There we go. So let's go to the... Actually, we can stay at the very bottom and check this. 90, 69, 11, 39. Okay, we've now got these numbers. And we've got them correctly available. So with these numbers, we now need to... I assume it would be just trying every possible combination. And it said maximum presses of 100. So we could do for button... Oh, we can do A press equals 0, A press less than 100, A press plus plus, and then we do the exact same thing but for B. Now we put that in here, B, B, B. So we start off at 0 because there's the possibility that don't press A at all, but then we press B a heap. So we now need to figure out, so it would be like, so if the amount of button presses is correct, we'll do E. So if AX times A press plus BX times A press is equal to PX, and we do the exact same thing, but changing it to Y and equal to PY. Okay, we also need to keep track of min cost. Now we'll make this make a -1, then we'll do found is equal to false. So if this is the case, now we do cost is equal to A press times 3 plus B press times 1. So we do that. Now we do if found, not found, or cost is less than min cost. We then do min cost equals cost, and also found equals true. So if we've got all this, then it is if found, we'll do output plus equals min cost. So let's run that and see if we've got it working. Don't think that number's correct, but we can enter it and see. No, it's not correct. So we'll go back and let's put in the practice example and see what it makes. Okay, well it's saying 0. I found the mistake. 480, 480. So now let's switch that back and now we should get the result. 30413. That looks more like it. And that is part 1 done. Now on to part 2. As you go to win the first prize, you discover that the claw is nowhere near where you expected it would be. Due to a unit conversion error in your measurements, the position of every prize is actually this number higher on both the X and Y axis. So add that to X and Y of every prize. After making this change, the example above would now look like this. So now it is only possible to win a prize on the 2nd and 4th claw machines. Unfortunately, it will take way more than 100 presses to do so. Using the corrected prize coordinates, figure out how to win as many prizes as possible. What is the fewest tokens you would have to spend to win all possible prizes? Okay, so this is another one where I spent ages working on it and I just don't know what the solution is. I don't know math, so all these math ones don't have a clue. So I was originally trying to use the greatest common denominator, find number between the two X's and the two Y's, the greatest denominator between them, and then use that as a way to press the buttons quicker or something. I'm not sure, but this is a solution I found. I don't know why it works. So AX times BY minus AY times BX. So if DET is equal to 0, then that means there is no solution, which I'm not sure why. And then apparently you can get the press by doing these equations, and if you do that, then you can figure out whether... So then with doing that, you can get the amount of presses you need to do and the cost. So with the test one, we've got this massive number. I'm going to switch to the actual input. We run it. We've got this big number, so let's submit it, and that's correct. So if any of you have a clue as to what this math is doing or anything, please let me know in the comments below, because I don't have a clue, as I've zero background in math. I know the absolute basics and that's it, but apparently this works. So that's that answered. If you like this video, make sure to like and subscribe.